Hey everyone, welcome back to the Data Science Interview Question Series. In this video, we will try to solve a real world problem with logistic regression. Suppose you're a machine learning engineer at Facebook and you're working on a low latency application. Now let's turn off the music and try to understand the problem statement. You need to optimize the inference time of the logistic regression in case of higher dimensional data for your low latency application. Let's make the problem statement more concrete. The current inference time is 100 ms using the best possible hardware that you have access to. Now you're supposed to decrease the inference time to 95 ms so that the low latency application can run. Now pause the video and try to think how you can actually optimize the inference time. Okay, before we move on to the solution, I would like you to hit the subscribe button and push the bell notification so that you never miss an update for the next important interview question. So before jumping on to the higher dimensional, let's see how the calculation happens in a 3D, three-dimensional logistic regression. So we have three different input values, x1, x2, x3, and three different weights corresponding to three different input values and a one bias. So in total, we will be doing three multiplications and three additions. But what about the 1000 dimensions? Let's try to extend the same equation for 3D logistic regression to 1000 dimensions. Awesome. So we have actually extended the 3D logistic regression to 1000 dimensions, and we have total 1000 different weights corresponding to 1000 different features and again one bias. So in this case, we will be doing 1000 multiplications and 1000 additions. Before we move on to the analysis of 1000 dimensional data set, let's try to visualize the lower dimensional data. So this is the two-dimensional data that you had. Is it possible to find the hyperplane? Let's try. With this hyperplane P1, I will still misclassify a lot of green points which are behind the red points. Okay, let's try another one. Okay, with P2 again, there are again a lot of green points which can be misclassified as red. So in short, we actually cannot find out the ideal hyperplane for this data set. But how about if we do transformation from 2D to 3D? Yes, the answer is yes, because here we can actually find a hyperplane which separates both 2D and 3D data pretty well. So with more dimensions of features, there's a high chance to find the hyperplane which separates the data into classes. Few observations up until this point. It is comparatively easier to find the hyperplane in higher dimensions which separates the data into two classes. For 1000 dimensions, we're supposed to do 1000 multiplications and 1000 additions. Since all the feature weights actually don't carry equal weights, so is there any way we can get rid of those features which has lower importance? Turns out the answer is yes. L1 regularization comes to the rescue. Since applying the L1 regularization leads to zeroing out of least important feature weights, therefore we can actually get rid of k percentage of least important weight parameters. So let's try to apply L1 regularization for three-dimensional data set. So the equation would look something like this. Let's try to plug in the weight values as well. So the weight values will look something like this. Out of this, 0.1 is of least importance because it has the least magnitude. But still, we will be doing three multiplications and three additions. After applying L1 regularization, we actually get rid of 0.1. In turn, we actually do just two multiplications and two additions after L1 regularization. In short, we have removed one less important feature. But what about 1000 dimensions? Now let's rewrite the same equation of L1 regularization for 1000 dimensions. This will look something like this. After regularization, we can actually get rid of 100 less important feature weights. And now we will need to calculate just 900 multiplications and 900 additions instead of 1000 multiplications and 1000 additions. This will most likely bring down the inference time from 100 ms to 95 ms. There's some chance of underfitting the model, but we are still having 900 dimensions, so those should take care of that. With that, you can actually deploy your low latency application. Let's summarize all the points. Remember guys, this is how you will be speaking in an actual interview. Since the data set is of higher dimension, we can actually get rid of features with less importance with the help of L1 regularization. Removing the less important feature will bring down the inference time so that you can actually deploy the application. Although there is some chance of underfitting, but we are still having about 900 features, and that should be able to take care of the underfitting problem, and the model should be able to generalize well. If you find this video helpful, please consider subscribing. Also push the bell notification so that you never miss an update for an interesting interview question. Who knows, this might be your next interview question. Also, if you have any suggestions for other topics, please let me know in the comment section, and I'll see you in the next video.